So what about multi-class problems? Many classes, not just 0 and 1, right? I have like 5 classes that I could assign labels from, right? So what about multi-class problems? For multi-class problems this kind of simplification is actually not possible, right? So we have to end up using some heuristic or the other, right? So typically what people do is they end up doing some kind of very rough clustering on the values that attribute can take, right, and then try to define split points based on that, okay. And yeah, so I am not going to go into the details of the heuristics. I mean, if at all you are going to use this, then you will probably be using a package, but it will be good to read up some of these if you are interested. Okay. So as you can imagine, as soon as you enter heuristic territory, right, everyone can have their own favorite heuristic. So there are many that have been proposed in the literature, such as guide, quest, cruise, fact. So one of these annoying things in many of this machine learning data mining literature is people sometimes go out of their way to come up with pronounceable acronyms, you know. So people have clustering algorithms called chameleon. Imagine how much work they must have gone to produce chameleon as an acronym, right? And right. So in fact I think in fact what you essentially end up doing is you use some kind of indicator variables, right, for each of these, right. This is something I think you suggested that, right, you use an indicator variable for each of these dimensions, and then they try to do some kind of dimensionality reduction on that, right, try to pick a discriminating direction, right, and then project onto that, and then use that dimension for splitting. Suppose I want to split on color, right, I will not do it on color, so I will create 5 variables, okay, which is essentially one variable for color is red, one variable for color is blue, one variable for color is yellow, and one variable for color is magenta, but I will not use those as Boolean variables, right, and I will try to find some kind of a projection from this 5 dimensional space onto a single dimension, and then treat that single dimension as a continuous dimension and try to do a projection on it. It essentially ends up doing some kind of clustering, ends up doing some kind of clustering on that one dimension. Okay, we'll talk about clustering little later, but you know what clustering is. I already told you what the problem is in the very first class. Okay. The other approach to doing this is to do multi-way splits. So what do I mean by that? If I decide to split on color, or I have to evaluate color, instead of splitting it into 2 groups, I will split it into 5 groups in our case, in our example, because we have 5 values color can take, I will split it into 5 groups, right. So in my decision tree, instead of always looking like this, will suddenly start looking like that. Okay. So what are the problem with multi-way splits? Why don't we use multi-way splits all the time? Huh? Too much computation. In what way? Not each of the class, right? Why are we determining the split points for each of the class? We are talking about an attribute that describes the data, right? Is that some confusion people are having here? When I talk about categorical attributes, I am talking about attributes of the data other than the class label, right? The class label will always be categorical, right? If it is continuous, then it becomes a regression problem, right? but then the values that are describing the data itself, we normally assume that x comes from RP, right. So I was telling you that that need not be the case, right. If suppose you are filling out a survey form, you instead of filling in your age or something, you are going to say less than 25 or something, right. So in such cases, how will you test on that variable, right, how will I split on that variable, that is the question we are asking. So now instead of saying that you see less than 25 and between 25 and 35 will go left, and greater than 35 and greater than 45 will go right, instead of saying that I am saying okay, this will be less than 25, this will be between 25 and 35, this will be between 35 and 45, this will be greater than 45 or something like that, and splitting it all the ways in one go. It really does not, it is a little bit more computation, because when you are computing the score of each attribute, right, you will have to do some additional work, but it is not too much. Okay. What is bad is it, no.
So after this, if you want to prune back, you might have an issue. You'll again, you'll have the same issue, right? You won't know which part to. You can't. You either.
Yeah, but pruning you always remove the whole subtree, right?
Yeah, but then over here we either take that full set or not, and you might have a better solution if you have part of it in one and part of it in the other.
Yeah, so interpretability becomes a casualty, right. So because if you are going to have multi-way splits, it becomes harder to interpret, so the tree becomes very sprawling, right. So remember, one of the biggest advantages of decision trees is that they are easily interpretable. Now if I am going to say okay, there is this 10-way split and then you have to go down the 10-way split and go down further, then it becomes harder to interpret, right. So like she was saying, you might lose insights, right, that is essentially saying that some amount of interpretability is lost. But there is another problem with having sprawling trees.
Variance is more.
Yeah, so variance is more, but the related problem to that, right, is the fact that if I do this multi-way splits, the amount of data that is available might come down drastically, right. So each path might have, suppose well, let us say magenta is a rare color, right. So here that has nothing to do with this 0.55, okay. Magenta might be a rare color, right, it might be just only 10 people in my million customer database ever have magenta color shirts, okay, right. But then 55% of them might be positive, I do not know, see that has nothing to do with it, right. So how predictive it is of the positive class has nothing to do with the size of the population there, right. But the problem is I will only have 10 people here on which to make further decisions, right. So if I am going to do this multi-way splits, I will run into data sparsity problems very quickly, right. Does it make sense? I mean these are all, I really can't ask you questions in exams or things like that with all of these things, more like practical guidelines for you to when you actually start using these algorithms, what are the things you should be watching out for, right. You should, when you are using decision trees, you should make sure that you are not running out of data points very quickly. If you run, if some branch in your tree becomes sparse quickly, right, then it becomes harder for you to trust the tree, okay. And this is related to the variance question, because if you are making decisions based on very small number of data points, then naturally the variance is going to be high. Yeah.
How do we split, like multi-way splitting, like for each attribute value you make a
different branch in the tree, that is what I said, right. So if you want me to actually fill in some things here.
How do we compare two choices of splitting?
There are no two choices. When you pick it, that's the whole point. I am eliminating the whole question of splitting picking a split point, right. So at the color attribute, I will say color not is, sorry, color equal to R, you go that way. Like that. So this is essentially how your tree will look at. Right, so this is how it is going to look like. Yeah.
After splitting the attribute, then you do the regular decision.
Exactly. So this is no. So See, you remember you compute the quote unquote the utility of splitting on a particular variable, right. So, you pick a split variable and then you find the optimal split point in that split variable and then you look at what is the least quality whatever you can achieve, right. We looked at squared error, we looked at entropy and whole bunch of other things. So, you essentially look at that. So, here instead of looking at the best possible split point, once you pick an attribute you split on all the values the attribute can take and then compute the measure, whether it is squared error or entropy or whatever it is, you can compute the measure. So, all the measures we talked about weren't contingent on the split being binary, right. Essentially you just looked at R1, R2 for simplicity's sake, but I could have had R1, R2, R3, R4, R5 and I was computing the expression. If you don't, and if you can't relate to what I am saying, just flip back. If you actually were taking notes, you would know what I mean, right. So, when we are looking at the squared error measure, right, I wrote down as R1 and R2 where R1 was it is lesser than J and R2 is greater than J or something, right, or S, whatever is the split point. But here we do not, there is no choice of what is an optimal split point here. Once you pick an attribute you split on all the values it can take. So, it becomes sprawling. So, that leads to so, if you are doing this multi-way splits, it is going to naturally favor attributes with more values. Say let us say I have color and then I have something else like age, and color has 5 values and age has like 15 different bins I have split age into, right. So, when I split on color I will split into a 5-way branch, when I split on age I will split into a 15-way branch, right. Of course, there can be exceptions, but I would more likely to find purer leaves when I split into 15 than when I split into 5, right. I split it into 15 ways, I am more likely to find leaves that are pure, right. If I split into 5 ways I am less likely to find leaves that are pure, right. So, just pure in the sense they have the same class, right. So, this kind of multi-way splits tends to favor attributes with more values, right. So, that is not necessarily the best way of doing the splits because you might not be generalizing properly later, right. So, for this people use all kinds of tricks. So, there is a very popular decision tree algorithm called C4.5 which uses something called gain ratio. So, people recall information gain that we spoke about in the last class, it is related to entropy, right, the information gain thing. So, information gain tells you how much less information you need, right, by splitting on a particular attribute for encoding the class labels, right. So, what gain ratio says is, hey, forget about the fact that I have this variable, suppose I split the data into 10 ways randomly, okay, how much information would I gain, right, versus splitting it into 10 ways based on this attribute. You see the difference? I take the data, split it into just randomly split it into 10 groups, right, or I take the data and split it into 10 groups based on this attribute, okay. So, that ratio is what I will use, okay. So, if I could have arbitrarily split the data into 10 groups and I would have still gained the same information as splitting on this attribute, then I do not want to split on this attribute, right, it is no better than random, right. And heaven forbid if the ratio is less than 1, I really do not want this, right. So, the ratio should be higher than 1. So, that is what I will be looking for. So, I can instead of using information gain I will use gain ratio, and likewise you can order this for any of the attribute any of the measures that you use, right, you can always adjust it for random splits, right. So, that is essentially what we end up doing, right. So, do you gain anything special about expressive power for the tree by doing multivariate splits? As the tree become more expressive in the sense that can it represent more functions than you could with binary splits? No, whatever I do with this multivariate splits, I can do recursive binary splits and I can achieve that. It's not adding to the expressivity, it just avoids the question of picking a split point, right. That is not a trivial thing, okay. You have to come up with all kinds of heuristic to split points, to pick split points, but still if you can, okay, the recommendation is to avoid multivariate splits, right, and stick with binary splits, but in some cases it is just easier to do this, especially if the number of ways in which you will split is small enough. Okay, if you are not going to split it into 20 different things or for 50 different things, right, you can still do multivariate splits, like 5 or 6 should be fine.